So clearly, one of the products of the reaction between magnesium and hydrochloric acid is hydrogen gas. And this allows us to roll these two out, and this one, and we can now definitively say it's either this or this. So at this point, to determine whether this is the right side of products or this is the right side of products, we may have to rely on experience, intuition, or rely on other people's research. And some of the greatest chemists in history were famous for just having like a deep intuition for what was happening inside of chemical reactions. And so for this, I would say let's go to some literature and the experience that other scientists have brought to us. And that is chlorine gas, I can tell you, is quite toxic. I believe it's pretty deadly. And so if you haven't died, I didn't die, and I did this experiment, we can probably rule out the fact that we're producing, we could probably rule out the possibility that we're producing chlorine gas. And this then leaves this as the answer to the challenge. We are producing magnesium chloride and hydrogen gas. So let me erase everything I have and let's write down the proper chemical equation in full. So let's just remind ourselves that all chemical equations list the reactants on the left side and they become the products which we write on the right side. And we know the reactants here are Mg and HCl, hydrochloric acid. And we know that the products are MgCl2 and hydrogen gas. And as alluded to before, chemical equations are designed to communicate a lot of information, and a way to sort of pack more information into this simple statement is we indicate the state of matter of these four chemicals. And so what I mean by that is we write an S because magnesium metal is a solid. And this is going to be new information for you. But we're writing AQ because hydrochloric acid is soluble in water. So it's swimming around in water. AQ means aqueous, which just means it's soluble in water. Magnesium chloride is an AQ because it's soluble in water. And hydrogen is a G for gas. So there's one final thing to do to make sure we are truly obeying the conservation of mass. So of course, as we have written it, we're not producing any new types of atoms, but we have to make sure that the number of atoms over here is the same as the number of atoms over here. And the way we do that is we write numbers in front of each of these chemical species to make sure that the amount of atoms over here is equal to the amount of atoms over here. And the number indicates the amount of these things that are taking part in the chemical reaction. So we want to make sure that the number of atoms of each type are the same on each side of the equation. And so let's start with magnesium. I have one magnesium here and one here. So that's cool. We don't have to write anything. I have one hydrogen here, but two hydrogens here. That's a problem. But there's a quick solution. If I just write a 2 here, now I have 2 molecules of hydrochloric acid. So I could just write that just sort of picture that like this. I have 2 of these. And I have 1 molecule of H2, but that means I have 2 molecules of hydrogen, so I don't have to write anything there. And now I want to look at the chlorine. Because I have 2 molecules of hydrochloric acid, I have 2 chlorine atoms over here, and I already have 2 chlorine atoms over here. So I can write a 1, a 1, and a 1 here, and now it's balanced. And one last thing, whenever there's a 1, and by the way, this number before the chemical is called a coefficient. So whenever 1 is the coefficient, we can actually just ignore it. So if there's nothing before the chemical, it means a 1. And so this is a fully balanced chemical equation obeying the conservation of mass. And one last thing to touch on, which is kind of the most profound thing, is we truly are getting inside of these chemicals and figuring out how they are rearranging themselves during a chemical reaction. So all that fizzing that we're seeing and all that gas being produced, we actually know what the atoms are doing based on this chemical equation. That's how much information is packed into here.